Okay, so moving on to the next topic, we have processes applicable to ideal gases. So we have isothermal process, which is also called hyperbolic. So here the temperature is constant. I already discussed this earlier, how to do this, the P1 V1 equal to P2 V2. So if the process is isothermal, so of course the delta T, or change in temperature, is 0, and change in H and change in U are also 0. General formula is work is equal to the integral of P dV. Of course, so applying the integral here and considering that PV is constant, so P is equal to C over V, right? And then um, substituting that to the formula, you'll have something like this. So integral of V1 to V2, C over V dV, okay? And then applying the integral, you have a formula something like this. Okay, so I won't be reading that anymore. So next we have the isobaric process, which is the pressure is constant. Now Q now here will be just equal to the change in H. So work here will just be this one again. So integral of P dV, and pressure of course is constant. So you just have a simple formula of P times the difference of volume V2 minus V1, or change in volume. Now change in U here is mcv delta T, of course, and change in H is mcp delta T. And then Q here will be change in U plus work. Now as isovolumic process, so we have isovolumic, isometric, isochoric. That is a volume constant. So I already discussed how to do this. And of course, the general formula again, and of course, volume is a constant. Since volume is constant, there is no dV. dV must be equal to 0. Therefore, work is 0, right? Then Q is still delta U plus W. However, work will be equal to work is equal to 0, right? Therefore, you'll just left with this and delta U. But delta U is also equal to mcv delta T. Now, reversible adiabatic process. So in this case, there is no heat loss or no heat gain. Therefore, Q is equal to 0. Okay, so the isentropic process. So entropy, what is entropy? Entropy is the measure of randomness or disorder, right? And amount of energy not available for work. So isoentropy, that is the S is constant or the entropy is constant. Therefore, if that is constant, there is no change in entropy. And we also have the adiabatic constant, which is the K, that is just the Cp over Cv. I already discussed the formula earlier also. Now, of course, the general formula is this one, and then you'll have something like this, and you'll eventually arrive at a formula something like this. Okay. So we have here the polytropic process, which is similar to the adiabatic isentropic process. So PV raised to n is equal to C. That is now the constant, but remember that n is not equal to k, because k is your adiabatic constant while n is your polytropic index. So be careful with that. Of course, we'll be using n mostly here because that is a n is the polytropic index while k is the adiabatic constant. You'll be using k when it is an adiabatic process, and n if it's a polytropic process. So if n is 0, p is constant. Okay, so that is isochoric process. If n is infinity, therefore v is constant. That is an isometric process. And you'll arrive in a formula something like this. Okay, so v1 over v2, that is the ratio of the volume. That is also called as the compression ratio. And it is also denoted as R. Okay, so again, using the general formula for work, you'll arrive at a formula something like this. Now, for number 6, we have the throttling process or isenthalpic process, or we also call it isoenthalpy. So, a flow process. Now, this is now the open system. Okay, this is now the open system. So you can see previously we only have a closed system. Now this is an open system. Now the mass can now cross the boundary. Okay, so H must be constant. Therefore, there is no change in H and there is no change in temperature. So these are the formulas for the change in entropy. Okay. Oh, I think that's it. Let's have some sample problems.